Hello students, sorry for the inconvenience occurred due to the Zoom video because they are giving 40-minute free video meeting only. So I have thought of uploading this video which will beneficial for you. It's better you don't attend the class but you just attend my lectures virtually at your home. So we ended up till this formula, that is the section modulus at the top and the section modulus at the bottom. So FTR and FTR represents range of the stresses at the top, FBR represent the range of the stresses at the bottom, and we know that eta is the loss ratio. Eta is the loss ratio, that is for 0.75 to 0.80. It is for pre-tensioning. It is for pre-tensioning, right? And it is 0.80 to 0.85 for post-tensioning. For post-tensioning, it is 0.80 to 0.85. So obviously we can see that the loss ratio in post-tensioning is more than the loss ratio in pre-tensioning. Okay. Now coming to our other formulas. What are the other formula? Now the formula is based on the prestressing force. I told you that while doing this topic, design of flexure, we had three main criteria. We had to find out the section modulus, we had to find out the prestressing force and eccentricity. Now there are two critical combinations I told you. First critical combination is the maximum prestressing force during transfer along with minimum moments, and the second is minimum prestressing force after the losses with maximum moments. So now our next phase of this topic is prestressing force. So in prestressing force, whenever we are talking about prestressing force, so this prestressing force, it can be applied for upper and lower permissible limits. Upper and lower permissible stress limits. Upper and lower permissible stress limits. Okay. Upper and lower permissible stress limits. Okay. Now for prestressing force, there is a criteria. What is the criteria? To get the maximum prestressing force, we will have the maximum tensile stresses at the top fiber and minimum compressive stresses at the bottom fiber. What is the criteria? The main criteria is, if you talk about the criteria is to obtain maximum prestressing force. To obtain maximum prestressing force, we have to have sorry for the inconvenience, maximum tensile stresses at top fiber. Please keep this in mind. These are some of the small theoretical aspects in this topic. So for maximum prestressing force, we will have maximum tensile stresses at the top and minimum compressive stresses. Obviously the stresses are pre-stress. Minimum compressive stresses at bottom fiber. Okay. So maximum tensile stresses at the top fiber. I think the video is going on. Thank you. Maximum tensile stresses at the top fiber and minimum compressive stresses at the bottom fiber. Now, what are the formulas? The first formula is, we know that F superior, the formula is F superior plus, so F superior is greater than equals to FTT minus mg by zt. FTT is minus mg by zt. This is the first formula we know. Sorry. F superior is greater than FTT by mg by zt, and the second equation is F inferior should be greater than equals to FTW by eta minus plus mg plus mq divided by eta into zb. So this formula is nothing new. How? If you see the original formula which I discussed, the first four formulas in this topic, F superior, if you see the inequality or inequation, F superior is greater than FTT minus mg by zt, and the second equation, F inferior is greater than equals to FTW by eta plus mg by mq by eta zb. So this has come from the equation 1. The first equation which we have done in this topic, the design for flexure, and this equation has come from equation 4 of the first four equations. So these two equations we have to keep in our mind, and from this we will derive two final formulas in this topic, that is the prestressing force and obviously the eccentricity. Now obviously there is another thing which I wanted to mention, that is we have these, but we have these FTR and FBR. So also we have another separate set of two equations, one for FTR and one for FBR. FTR will represent the range of stresses at top. FBR will represent range of stresses at the bottom. So now all these formulas which I have discussed, obviously they will be used in the problem. Another set of formulas, some other important formulas which we have to apply in our problems. Some other set of formulas. क्या है? First is obviously the FTR. I told you that is the stress at the top. So FTR is greater than equals to MQ plus 1 minus eta mg by zt, and this should be equals to greater than equals to, obviously these are all not greater or lesser, these are greater than equals to. While solving the problems, we will use the equation equals to. So we will use the equality function. In all these permissible stresses for lower and upper limits, we have represented inequality, but while going for design or solving the problems, we will use the equality symbol. So FTR greater than equals to MQ plus 1 minus eta mg by zt, which is greater than equals to FCW, very important, FCW minus eta FTT. So this portion, obviously both are important, but this portion of the formula is more important. This portion of formula is more important. That is FTR should be greater than or equals to FCW, that is the compressive force at the working load, minus eta, if I put eta much better, FCW minus eta F tensile at the transfer. The second equation, obviously it will be for FBR, the range of stresses at the bottom, it should be obviously greater than MQ plus 1 minus eta mg by ZB, which is again greater than equals to, very important, eta FCT minus FTW, eta FCT minus FTW. So eta FCT, obviously FCT is the, this one, FCT क्या है? FCT is the stress, compressive stress at transfer, FTW tensile stress at the working load. Okay, so again this equation we are somewhat getting from the first four equations, the first four primary equations which I discussed in the beginning of this topic, in the last class. Okay, no problems. Now we will do we will equate, or we will find the formula for prestressing force. The third equation is the equation to calculate the prestressing force. See, so the prestressing force is a very important formula. So prestressing force equation, that is P. So here we will calculate P equals to the derived formula. You don't have to derive it, just you have to use the formula in the problem. A multiplied with F inferior ZB, F inferior ZB plus F superior ZT divided by ZB plus ZT, ZB plus ZT. So this is another important formula. This formula we will use to calculate the maximum prestressing force, which I told you. In the topic of design for flexure under serviceability limit state, The maximum prestressing force is A means the area of the section, F inferior, that is the stress at the bottom, multiplied with section modulus at the bottom, minus F superior, sorry, it's not minus, it's plus F superior, that is F at the top fiber, multiplied with section modulus at the top fiber, divided by Zp plus Zt. And the fourth and the last equation in this topic is the eccentricity. Eccentricity. Achha. So what will be the eccentricity? This is again derived E is equals to Zt Zb inside brackets F inferior minus F superior divided by A into F superior Zt plus F inferior Zb. So this is the equation, very important equation to calculate the corresponding. So in this topic we have learned the equation for top fibers, range of top fiber, range of bottom fiber, prestressing force, maximum prestressing force, and the associated eccentricity with the prestressing force. The associated eccentricity with the prestressing force. So this is the thing which we have to use to solve the problems, the future problems. So now you will have today the topic or the problem which I will discuss. Similar type of problem you have in an assignment. If I bring out the assignment sheet, so this is the assignment sheet, you will have similar type of question in an assignment. The question number is question 6. Question 6. So let's start with a problem in this topic. So obviously I told you, so I've discussed all these type of formulas. Now while doing the problem, I have told you that I will not go into details of the discussion of the problem. You have the notes with you. I will just discuss, or I will teach you the concepts involving how the concepts are applied in the problems, and I will discuss the problem statement in short. I hope everyone is doing their assignments time to time, and you have to submit just when the college reopens. So these are the various formulas. You have to use the box. While keeping the box, you will have to picture. So this and these 4 equations you have to memorize. These 4 equations you have to memorize for in this topic to solve the problems. So now the problem is with you, the problem statement is with you, and you have also the solution. What is the problem stating? The problem states that we have a post-tensioned beam, we have problems. This problem will be similar to assignment question 6. This type of problem you will definitely get of 7 to 8 marks. Assignment question 6. Okay. Now what is the problem saying? It is given that it is given that we have post-tension pre-stressed beam, the width is given, the width we have here B equals to 250 mm. For example, I am just showing the tendons. I don't know how many tendons are there also. So I am just arbitrarily, and H is not given. H we have to find out. A post-tension pre-stressed beam of rectangular section 250 mm is to be designed for imposed load. Imposed load, it is given. So obviously imposed load will be the live load. Imposed load will be the live load Q. It is given 12 kilonewton per meter. The span length, sorry for the inconvenience. Imposed load is given 12 kilonewton per meter, and we have the span length 12 meter. Okay. The stress in the concrete should not exceed 12 Newton per millimeter square in compression. That means stress in compression at any stage should not exceed 17 Newton per millimeter square, and it is again given the tension in any time should not exceed 1.4. So Ft should not exceed 1.4 Newton per millimeter square. So it is given that the compression at any stage, that means at transfer and also in the working load stage, the compression stress should not be more than 70 Newton per millimeter square, and the tension should not be more than 1.4 Newton per millimeter square at both these stages, that is the stage at transfer and stage at the working load. Now the loss of pre-stress is given 15%. The loss of pre-stress is given 15%. That means our loss ratio is 0.85. So 100 minus 15, 85%, that is the loss ratio is given 0.85. So whatever we have to calculate, the things we have to calculate in this section. Very important question. Please make it a very triple star. This type of question will definitely you will get, and very easy. We have to calculate first the minimum depth possible for the beam. We have to calculate the minimum depth possible for the beam, because I told you the depth is not given, depth or h, whatever you can tell, no problem, depth or h, d. Okay, so please remember this is not effective depth, it's better I represent capital D. So capital D, it is given that calculate what will be the possible depth for the beam under so much criteria. And the second question is asking for the section provided. So for the section of the beam obtained, calculate the prestressing force P and obviously the associated eccentricity E. It is telling me that it is asking me to calculate, it is asking me to calculate the prestressing force and the associated eccentricity with this prestressing force. Okay. So now let's start with the problem. Okay. Let's start with the problem. So this is the question. We have imposed load 12 kN per meter. We have span length of 12 meter. At no condition the stresses in the compression zone should not be more than 17 and the tension should not be more than 1.4, and eta is given 0.85. so the loss ratio is not directly given, the loss percentage is given, so we have to subtract this from 100 and find out the loss ratio. Now we have to calculate the minimum possible depth D, and obviously for section of beam calculate the prestressing force and eccentricity. Now bachcho, in this question, students, please listen to me. In this question, it may be given that the depth is given, the breadth you have to find out. Either or. Okay? Either the breadth will be given, depth you have to find out, or the depth will be given, you find out the breadth or width. So now starting with the problem. You have the solution with you, but please listen to this lecture. We have similar question also. See question number 6 as well as question number 14. Question number 6 as well as question number 14. We have a similar question. Both questions are important for your examination. Question number 6 as well as this question. Question number 6 and question number 14 both are similar. Just some values are different. So now coming to the solution, it's not the liquid solution obviously, but the answer for the problem. So it is given that, so we have B is given 250 mm, depth we have to find out, eta is given 0.85, okay. So now as per permissible limits, it is given that means what? Compression. So first we are taking the stresses for compression. So FCT, that is the compression at transfer, is equals to compression at working load, FCW is 17 Newton per millimeter square. We take compression as positive and tension as negative. If you see the Krishna Raju book, in the Krishna Raju book of Prestressed Concrete, they have taken the tension as positive, they have taken the compression as positive and tension as a negative. And obviously we have given that tension, FTT is equals to FTW is equals to minus 1.4 Newton per millimeter square. I told you by solving the problems we do not take the inequality but we take the equality symbol, and tension is negative. Okay, tension is negative. So now we have to calculate obviously So your brain will obviously instigate, दिमाग में ये चलना चाहिए कि whatever the formulas I have set for you, from those formulas only we can easily solve the problem. In the part 2 of this problem, you can see we have to calculate the maximum pre-stressing force and eccentricity, which direct using the application of formula we can find out. I told you the formula for pre-stressing force and eccentricity. But to calculate this depth, what should be the formula? To calculate the depth of the formula, we have to use the help, we have to take the help. See, very important, it's an important trick. Case A. What is case A? To calculate the depth, whatever the things we have to find out. To calculate the depth D of the beam, first we have to calculate the what? The range of stresses at top fiber, FTR. We have to calculate the stresses at FTR, okay, or we can calculate the stresses FBR first, and then we have to use the concept of section modulus. We have to use the concept of, or the formula for section modulus ZT or ZB. ZT or ZB. So we have to calculate the depth of the beam. We have to use the FTR or FBR, and in the problem solution we have used FBR to calculate FBR. So if you use FBR, then you have to use ZB. If you use the formula for FTR, then you have to have the formula for ZT to then calculate find out the depth of the beam. So now we have given Q equals to, so Q equals to 12 kN per meter. So bending moment due to live load, that is the imposed load bending moment.